This is section 5.2, calculating due dates. So let's talk about calculating due dates with monthly loans. So if a term of a loan is given in months, the due date of that loan is a corresponding day in the maturity month. If the maturity month does not have the required number of days, then the last day of the month serves as the maturity date. For example, if you have a 2-month loan dated December 31st, there's obviously not a February 31st, so it would be February 28th, unless it's a leap year, in which there would be February 29th. If the due date falls on a non-business day, so like think about major holidays, the maturity date is the next business day, with the additional days added to the period for which the interest is charged. So let's find the maturity date for each of these. A 15-month loan is dated February 2nd. So to find the maturity date, okay, I know February is month 2 of the year, and I'm adding 15 months, so 17. There are 12 months in a year, so I'm going to subtract 12 to get 5. So it's the 5th month of the year, January, February, March, April, May. So we have May 2nd. A 4-month loan dated May 31st. So May, add 4 months. June, July, August, September. September does not have 31 days, so it's going to be September 30th. Okay, and then a 7-month loan dated December 4th, so add 7 months. So January, February, March, April, May, June, July. July 4th is a national holiday, so we go with the next day, so July 5th, and we're assuming that that is a business day. So if we calculate due dates with days, we have 2 different types of interest. We have exact simple interest, which is based on a 365-day year, including leap years. We just use 365 days. Ordinary simple interest is based on a 360-day year. It's also called a banker's year. Ordinary interest brings in the greater revenue to the lender. So find the exact and ordinary interest on a 60-day loan of $1,950 at 3.5%. So we remember that our simple interest is, I equals PRT. In this case, we know our principal is $1,950, and our R is 0.035. So we just need to find our time, and we're going to use that figuring out with these formulas we had on the last page. So for exact, we have 60 out of 365, and for ordinary, we have 60 out of 360. So to find exact interest, we take our 1950 times 0.035 times 60 over 365, and we get $43.27. For ordinary, we take our 1,950 times 0.035 times our 60 over 360, which gives us $43.88. Notice we said last time that ordinary interest brings in a greater revenue. Here, our ordinary interest is higher than our exact interest. And then talking about time, we have exact time and approximate time. Exact time is the count of the actual number of days, including all except the first day. So there's a table that I'll show you in a minute that has that. You can subtract the numbers of the given dates to find how many days. Approximate time is found by assuming that each month has 30 days, so 30 days for each month plus however many extra days. So we have this time schedule, okay? Notice that for leap years, after February 21st or 28th, you're going to add 1 day to the serial number for the day. Leap years are like 2012, 16, 20, 24, remember, every 4 years. All right, let's find the exact time from January 18th to July 9th of the same year when it's a leap year. So July 9th, if I look on the table, July 9th over here is day 190. but it's a leap year, so we have 191 minus January 18th, which is day 18. We have 173 days. That's the exact time. To find the approximate time, okay, I'm going to make a little table. So July 9th is, I'm going to make the month and the day. July 9th is the 7th month and the 9th day. January 1st, or January 18th is the first month with the 18th day. So kind of like subtraction when we borrow, I'm going to change July 9th because I can't take 9 minus 18. I'm going to change it to the 6th month and the 39th day. And then I'm going to subtract the first month and the 18th day. I get the 5th month and the 21st day. To find out how many days that is, I take 5 times 30, because there are 30 days in a month, plus 21.